Right, so here's video number 3. We're up to question 12. Question 12, we've got this question about the Christmas trees. We're given the data for the days and the percentage of trees left, and it then gives us the natural log of those two variables. So it says use the data in the second table, so ignore that first table. Use the data in the second table to find the values of M and B for the regression line. Right, this regression line, if we look at it, we've got something, our variable equals M times our variable plus B. This is linear. We are linearizing our data. So we need to use the linear regression function on our calculator. I think a few people just tried taking a couple of terms, like a couple of coordinate pairs, and like finding straight lines between them. It says in the question to do regression. So we're putting the data into two variable stats. We're just doing a linear fit, and we're writing ln x and ln d instead of y and x. That's all there is to that one. Question 13 was actually done really well. Well done. Some really good attempts at that one. Question 14. Okay, I've written notation here. So this was a normal distribution question. Some people did quite a nice job of saying, oh, well, I'm going to let x equal the weight of a sack, and then saying that x is approximated by a normal distribution with a mean weight of 49.8 and a standard deviation 0.9. So we have to give the variance, and then doing this, and then going, find the probability that a sack is under its labelled weight. Okay, so the label weight is 50. All of this is important for trying to get some method marks. If you're not getting the answers right, having accurate notation is going to help you a lot with it. Part B caught out a lot of people. The lower quartile, that's the lowest 25%. So for part B, you're going to find some value of x, you can call it Q1 if you like, where if they're below that, they're in the lower quartile, so they're in the bottom 25%. And then finally part C, I think everyone was expecting a switch to binomial, but it wasn't. In part C, we're doing a linear combination. So you need to say, oh, well, I'm going to let some new variable equal all of these x's added together. So I think it said 10 of them. And then you need to look in your formula guide for that linear combination formula to get your new normal distribution. All right, question 15. I quite liked question 15, but it didn't go very well, I'm afraid, for a lot of people. So we're told the total length of y is equal to 15. So this is just a frame, which everything else is on the diagram. We're working in radians as well. Show that r equals 6 over 2 plus theta. Right, it's hard to tell where that is coming from at the moment. But the thing that we have been told is that the amount of y is 15. So that's all you can really go off, I think. So we're going to have to use that. So the length of y is made up of all of the edges of this shape. So looking at the top, I've got r, and then I've got this arc. The formula for an arc length is in your formula guide. We're working in radians, it's just r theta. So taking the top, I've got r plus r theta. I've got the same on the bottom as well, so I'm just going to times that by 2. And then I've got these 3 verticals, so plus 3. Okay, this is a formula that links r and theta. We've got a bit of work to do to make it look like that. So actually, let's take off 3, and I'm going to tidy up the brackets a little bit, so it's 2r plus r theta times 2. I think I'll divide by 2, gives me 6. That's good because there is a 6 in the show that. Okay, we want to make R the subject, so we've got to factor out R. If you've got your variable appearing twice, that's how you get it to look like it's suddenly appearing once. And then the last thing to do is to divide across. 2 plus theta equals R. And I guess I'll just switch it so it's the same as the answer. Okay, so that's part A. The faces of the frame are covered by paper to enclose a volume V. So we're now turning this into a solid. Find an expression for V in terms of theta. That means theta is the only variable we're allowed. Let's start with finding an expression for V. This is a prism because it's got a constant cross-section of that kind of that sector on the top. So to find the volume of the prism, it's in your formula guide. You find the area of a cross-section, which is the area of a sector. That formula is also in your formula guide. I think it's a half r squared theta. And you multiply it by the height, which is 1. Okay, so V equals a half r squared theta is a good start, but our formula here is in terms of r and theta. So we need to use part A. That's the whole reason it was to show that, because we're going to need it. So it is a half times 6 over 2 plus theta squared times theta. Let's tidy this up a bit. A half times 36 over 2 plus theta squared times theta. Okay, I think I'm going to cancel 36 and the 2. It's 18. And I'm going to try and make it a bit nicer. 18 theta, over 2 plus theta squared. So that's an expression for V in terms of theta. Find the expression dV by d theta. So we've got to differentiate that. Right, how can we differentiate it? What type of function is it? It's a fraction, which means it's a quotient. So we've got to use the quotient rule. Once again, get your formula guide. It's u over v. So u is 18 theta. According to the formula guide, we're going to need du by d theta. V is 2 plus theta squared. We're going to need dv by d theta. You might want to use the chain rule. You might be okay with this and go, I'm going to multiply, differentiate the outside. That would be to the power of 1. And multiply by the derivative of the inside. Well, that derivative of theta is just 1, so it's just that. 2 times 2 plus theta. And then let's find dv by d theta. Using the formula guide for our quotient rule, v du by dx minus u dv by dx all over v squared, squared to the power of 4. Okay, I'm going to do a minimal amount of tidying up. I'm going to cancel out, there's 2 plus theta in every term of our fraction. So I'm going to take 2 plus theta, 2 plus theta, 2 plus theta. And then the other thing I'm going to do is I'm going to write the 18 out the front of the bracket, because I think that that is more conventional. And I'm going to do 18 times 2 is 36 theta. I guess we could do a bit more, actually. We could simplify this numerator a bit more. I think if we expand it, we get 36 plus 18 theta minus 36 theta. And I think we can simplify that too. 36 minus 18 theta over 2 plus theta cubed. Okay, I'm very happy to stop at that point. I think I've definitely done enough. Then, last bit of question 15 is solve algebraically dv by d theta equals 0 to find the value of theta that will maximize the volume V. So this is kind of an optimization question where they've told you what to do. Sorry, this is taking up quite a lot of space. I can't believe they only gave you that tiny box for this whole question. There's a lot of work here. So we're solving this equals 36 minus 18 theta over 2 plus theta cubed. Right, let's multiply by the denominator. And we get this. Let's bring 18 theta over here. And let's divide by 18. Theta equals 2. I think that's all you need to do. Find the value of theta. They haven't asked you to find what the volume is. They've just asked you to find the value of theta. Tough question. It's towards the end of the test, so you can kind of expect some tough ones now. I think part A was tricky, but it was a show that, so you could still move on with B. But yeah, differentiating that was quite a lot of work. All right, but that's why we revised that calculus, isn't it, for a question like this? Okay, question 16, what have I said here? I've said go through question 16. Okay, most people started pretty well with this one. I think this is probably the last one we're going to look at, actually. So, position vector OS. Right, this is given by its initial position, 300, 100, plus its velocity times time. That's 12 over 15. Okay, a lighthouse is located at a point 129, 283. Find the value of t when the ship will be closest to the lighthouse. There's a few ways of doing this. I think the easiest way is to find the relative position between the two. So, just to have a little think about it, we've got some sort of origin that we're measuring this all from, O. We've got this lighthouse, which is somewhere over here, let's say. And we've got our ship, which is travelling kind of like this, S. If we can find a vector for S to L, then we can find when it is a minimum. To get the vector SL, we need S to L. So this is, let's zoom in here, let's have a little look. That's what I want to find. I need to go from S back to O. That's all right. I've got OS, I just reverse it for SO. And then I need to go from O to L. So if I start at S, go to O, then back to L, I've made it from S to L. Okay, so we want to go SO plus OL. I don't want SO because I've got OS, so I'm going to do the negative of OS. Okay, and then that will give me this vector from S to L. So we found an expression from S to L. So we're going to use OL. OL is 129, 283. And we're going to take away OS. So I'm going to take away this expression that I found in A for OS. Okay, let's just tidy this up. 129 minus 300 is negative 171. This is 183. Okay, and then I'm just going to put it all together. So my x is going to be minus 171 plus 12t. My y is 183 minus 15t. Now, that is a vector from S to L. We want to find the minimum distance, the closest to the lighthouse, so the minimum distance. So the distance is brought to us by Pythagoras' theorem. Don't know why there's a t on there, there shouldn't be, sorry, let's get rid of that. Minus 15t squared. Okay, if we graph this, we should be able to find the minimum. So, I have this in my, let's just check this, negative 171 plus 12t squared, plus 183 minus 15t squared, and then there's a square root over the whole thing, and then we get, okay, the extremum is here. Extremum, when x is 13, so when time is 13, they are 19.2 apart. So when t equals 13, hours, closest position. Okay. And then finally, just to finish the question off, an alarm will sound if the ship travels within 20 kilometres of the lighthouse. State whether the alarm will sound, give a reason for your answer. Right, let's get that distance. It was 19.2. Ship is 19.2 kilometres from lighthouse when t is 13. 19.2 is less than 20, therefore the alarm will sound. Okay, that is that vectors question done. Quite a lot of work. This is a really useful technique, this minimum distance in B. Comes up quite a lot in exam questions, so it's a really useful one to learn. Okay, question 17. This was a toughie. It was tough because the curve is being rotated around the y-axis. So let's just take a quick look at this as well. Sides of the bowl are formed by rotating the curve y equals 6 ln x about the y-axis. Bowl contains water to a height of h centimetres. Show that the volume of the water, and then we've got to show that. So we need to find the volume of the water. It's rotated about the y-axis, which means we're going to need our formula guide. Volume rotated about the y-axis. This is calculus, topic 5. And we're very much in the HL section here. Volume of revolution about x or y-axis. This is about the y-axis. So pi x squared dy is what we want. V equals pi a to b x squared dy. I'm writing the formula down because we can't have the formula guide open while I'm doing this. You don't have to write formulas down. Right, x squared means we want x as a function of y. That's the first thing we need to do. We've got y as a function of x. So let's divide by 6. And let's get rid of the ln. To get rid of the ln, we've got to raise everything to the power e. Okay, so x equals e to the power of y over 6. So let's get back to our question and think about what we're doing. We are, well, what are we integrating between? We're after the volume of the water. The water is up to a height h, and it must start at height 0. So it's from 0 to h. We then need x squared. So we found an expression for x, e y over 6 squared dy. Okay, great start. Next, I think I need to do a bit of work just to combine these. Using my index laws, a power to another power, we just multiply the powers. So instead of y over 6 squared, I'm going to have y over 3. You could use the chain rule for this, but, sorry, not the chain rule, we're integrating. You could use substitution for this, but it's one of those ones that are really worth trying to learn how to do. So it's just the fact that we're dividing by the derivative. We're dividing by a third. That's the same as multiplying by 3. Okay, I've integrated. I need to introduce my square brackets and my boundaries. And then we substitute the top boundary, pi times 3 times e to the h over 3. And then we subtract the lower boundary, pi times 3 times e to the 0. Okay, are we on the right track? Right, we've got the 3, we've got the pi, we've got an e. This is all looking pretty good. I'm going to just tidy it up. 3 pi e to the h over 3 minus e to the 0 is 1, so 3 pi. And then looking at where we want to go, we want to take that out as a common factor. There we are. A tough question. Probably don't do enough practicing these ones around the y-axis. So worth doing. And the tricky bit is remembering that this is x as function of y. Okay, part B, hence find the maximum capacity of the bowl. This was actually done pretty well by most people. Most of you recognised that that maximum is going to happen when h is 9. When h equals 9, we just substitute it in. V equals 3 pi e to the 9 over 3 minus 1. Put it into your calculator and you got your answer. So hopefully, if you made it to 17B, it's nice that you had a nice, easy 2 marks if you made it that far. Okay, folks, that is the end of paper 1. I'm going to make a similar video for paper 2 and paper 3. They'll probably be shorter because there's fewer questions. If you've got individual questions that I didn't answer, by all means, have a look at the mark scheme, ask each other. If you'd like to speak to me, please do. I am definitely feeling well enough to speak to you on Teams, so we can arrange like a 5-10 minute call, or speak to Mr. Amarante in your class and he'll be able to go through it. He's having similar lessons and similar conversations with his class at the moment, so he will know exactly what you're talking about at the moment. Yeah, so that's the end of paper 1. Do make sure you go through and do your corrections. It is a very valuable part of the learning process. Bye-bye.